All right, let's talk about square roots. What's a square root? Use this symbol for a square root. Very similar to dividing. And you're probably familiar with it, like the square root of 9, we say is just positive 3. Okay, it is a number, square root of 9. We're looking for a number who, when you multiply that number by itself, you get the number under the square root. Okay, you can find a square root in your calculator. If you have your calculator, your TI-30XS's, it's over the x squared button. So you can do second x squared, plug in 9, you get 3. Did you know this is the same as a fractional power, though? A square root is the same as a 1/2 power. So go ahead and do a little experiment with your calculator. Type in 9 and then use the caret and type in the fraction 1/2. You're going to get the same exact value. You might have to put your fractional power in parentheses to get the same value. Okay, pretty cool. All right, and we know, though, however, that if you take a positive number and square it, you get a positive number. If you take a negative number, square it, you get a positive number. Negative 6 squared, 36. Same as 6 squared. Okay? Now, if I asked you, hey, solve this equation. Now, you're probably thinking, Mr. Messenger, we got x squared, don't we have to move everything onto one side? Well, we could. However, that's really, really important when we have x squareds and x's. In this situation, we just have x squareds. Okay? Now, just by looking above, I know that if I take 3 and square it, I get 9. If I take negative 3 and square it, I get 9. So it looks like my answers are positive 3 and negative 3. Or, a little bit easier to write, plus or minus 3. And if I look at the above, I see that negative 6 squared is 36, 6 squared is 36, so that means my solutions to this are positive 6 and negative 6. Or we could write it a little bit easier. It's plus or minus 6. Okay, well, what we can do if there's only an x squared, there's no x's, and if it's just a product of x squared, okay, or just x squared, you don't see any other variables x's, we could take the square root of both sides. Okay? Or you can do the whole thing, but we'd like, with algebra, to just do both sides as long as you're doing the same thing. Now, if you plug in the square root of 9 into your calculator, it tells you it's 3, and that's correct. The square root of 9 is only 3. However, over here, my original value that's being squared is going to be a positive. Okay? However, we know that there are two numbers for x that, when squared, are going to give us positive 9. It's a plus or minus 3. So it turns out, if I'm taking a square root of something squared, it is like undoing what one does to the other and just giving us an x. However, the original x could have been positive or negative. Right? Negative 3 squared, 9. Positive 3 squared, 9. So the unknown value being squared that is being square rooted, the original value could have been positive or negative. And it's actually solving for x, we will remove the plus or minus and move it to the other side. It's like multiplying both sides by a plus or minus. And it's here how we get from here to just an x. We are undoing what the square is doing to x, but it's a plus or minus x, move the plus or minus to the other side. Now, most of you will go straight to, oh, x equals plus or minus 6. However, keep in the back of your brains for the future, if I asked you, hey, what's the square root of 36? Don't tell me it's plus or minus 6. Square root of 36 is actually just 6. Okay? To be a function, the square root, you're only going to get a positive number. But it's when we are using it to find this unknown value that you'll get a plus or minus with the original unknown. Now, why does a square root undo a square, besides the word square root being an undoing of a square? Well, there's one way we could think about this. If I took both sides to the 1/2 power, and we know a 1/2 power is the same as a square root. If I take a power to a power, what do I do with the powers? Like, tell me, what is x squared cubed? This is x to the 6. And how did you get x to the 6? You multiply the 2 powers. What is 2 times 1/2? Just 1. So this is why a square root will undo what a squaring is doing to x, so that I just get an x, but there's a little bit more to it. It could be a positive or negative, because a positive value squared is positive, a negative value squared is positive. Okay? So these are different types of quadratics where we just have x squareds, and turns out we can use our friend the square root or the 1/2 power to solve for x. Now, if I get x squared equals -9, does x equal plus or minus 3 as well? Discuss with your neighbors. Is 3 and -3 a solution to x squared equals -9? Or is it just -3? Or is it just 3? Discuss, please. Go. Well, please do me a favor if you're unsure. I just told you that a square root will undo what a squaring does, and the square root of an unknown squared is a plus or minus value. Type into your calculator the square root of -9. What does your calculator tell me? I see on Mr. Swanson's calculator, non-real ants. I see on Ms. Bushman's calculator, error. Don't worry about that. I see domain error on your TI-30XSs. Okay, that's because there is no number that when squared gives us a negative. So we cannot square root of a negative number, because x equals -3. If I square it, I get positive 9. X equals 3. If I square it, I get positive 9. So there's no solution here. And we'll start talking about real versus an imaginary. We'll get into imaginary numbers in the future. But right now, we'll just say there's no solution. Okay, again, there's no number that's being squared equals a -25. So there's no solution here. Now, this guy. What we could do is still do what we did last class. I could say x squared minus 16 is x plus 4 times x minus 4. That is one way to get your solutions, 4 and -4. This is what we learned last class. But now there's a second way. Okay? I could isolate the x squared, square root both sides, giving me plus or minus x equals +4 or x equals plus or minus 4. Knowing that we could have a positive or a negative number being squared to give us positive 16, we get that. Okay? Both ways will get you the same answer. It is up to you which way you prefer and which way you'd like to use. If I look at the second one, it is not readily apparent how to factor this. Am I right? Right? Doesn't seem like it. Turns out you could factor out a -3. But maybe instead of trying to factor this, I isolate the x squared by subtracting 75 and dividing by -3. Then all of a sudden I say, oh, I have an x squared by itself. I could square root or take both sides to the 1/2 power, giving me a plus or minus x equals 5. Well, x could have been positive or -5. The third one. It is not obvious maybe how to factor this. I'll show you both ways. You can either subtract 20 from both sides to get everything set equal to 0. And I'll get x squared minus 100 equals 0. That could factor to be x plus 10, x minus 10. That's one way to get my solutions 10 and -10. Or I'll add 80. I get x squared equals 100. I'll isolate my x squared, take the square root of both sides, plus or minus x equals 10. X equals plus or minus 10. Okay? You guys try. Another type of question, find the zeros. We know when you're trying to find the zeros, you're just replacing the y with a 0. Now you could factor this if you'd like to, or since we just have an x squared, add the 25, isolate the x squared, square root both sides, you get plus or minus, so the original value could have been positive or negative, move it over, x is plus or minus 5. The next one might not be obvious how to factor this. I could factor this as 10x plus 7 and 10x minus 7. But instead, let's add 49. Divide by 100. Square root both sides. You can either type in the square root of 49 over 100, or knowing from last unit that if you have a fraction to a power, it's the same as the pieces in my fraction to the same power, since it's like multiplication. I could take the square root of 49, which is 7. 7 times itself is 49. The square root of 100, which is 10, to get x equals plus or minus 7/10. Change the 6 to a 9. Okay. We tackle this one. I'd add 1, divide by 9. I could square root both sides, giving me plus or minus x equals the square root of 1 is 1, square root of 9 is 3, x could be positive or negative 1/3. Last one, and then we'll come back and finish during Genius Hour because we got more stuff to do. The length of a rectangle is 4 times the width. If the area of the rectangle is 256 units, find the length and the width of the rectangle. Hold on. Finish this problem before you pack up. Thank you. Area of a rectangle is length times width. The length is 4 times the width. The area is 256. I can replace L with 4W, and all of a sudden I get 256 equals 4W squared. Divide by 4, take the square root of both sides. You'll get a plus or minus answer. However, we're talking about a rectangle, so we don't want to say it has a width that is negative. So in this case, I would disregard the negative. 256 divided by 4 is 64. W squared equals 64. In this case, I would say W is just 8. Okay, we'll continue on during Genius Hour. I expect to see you all on time for Genius Hour. Thank you very much. Hi. So if we look at these three, we realize that if we isolate the x squared by adding 10 to both sides, and we take the square root of both sides, the square root of 10 is not an even number. Square root of 9 is 3. Square root of 10 is just the square root of 10. It's some number between 3 and 4, closer to 3. That is okay. Okay, you can type in the square root of 10 into your calculator, and you'll get a decimal. However, we don't want to leave decimals. We want exact answers. So sometimes it's okay if you have just the square root in an answer. Okay, go ahead and do the other two here. I subtract 40, divide by negative 2, I get x squared equals 20. If I take the square root of both sides, I plug in root 20, there's no whole number. However, the square root of 20 is a number, so we'll get x is plus or minus root 20. Both the positive and the negative root 20 will work. Next one, I end up with a fraction. I subtract 10. Divide by negative 3, I get x equals positive 10 thirds. Square root both sides, plus or minus x equals square root of 10 over 3. Just going to leave it like that. X is equal to plus or minus root 10 thirds.
Isn't it negative 3?
It is negative 3. I divided negative 10 by negative 3, so the negatives went away. The next three says find the roots of the following quadratic equations. What are you going to be doing here? What's the first step? Before I subtract 20. Yes, make sure when you know the roots, to find the roots, it's when y is 0. I'm going to replace all these y's with a 0, and I'm going to solve. What's up?
You're left-handed, right?
I am. I'm left-handed. Add 100, divide 15. I could simplify 100 over 15. Divide everything by 5, you get 20 over 3. Square root both sides, plus or minus x equals root 20 over 3. X is plus or minus root 20 thirds. Add 80, divide by negative 2. I'd get 40 equals x squared skip the step and just say x equals plus or minus root 40. The area of a square is 300 squared units. Area of a square is just the side length squared. If the area is 300 squared units, what would be a side length of the square? Just the square root of 300. Okay, the next problem is like similar to a CLEP type problem when it relates to this. If A equals 2B and 2AB equals 36, find all possible solutions for both A and B. Discuss with your neighbors. What do you think you should do here? What should we do here? Discuss, figure it out. What do you think? A equals 2B, 2AB equals 36. What should we do? Substitute. You mean like plug it in? Yeah, I mean like plug it in. A is 2B, take 2B, plug it in for A. Yep. Divided by 2.
No, I moved over the A.
Okay.
So I just put
That'll work too.
A there. I know.
So it's 2B, B. Yep. 2B is what? Yeah, equal to 36. But what is 2 times 2B times B? 4B squared is 36. Divide both sides by 4. Square root both sides. You'll get your solutions for B. I want the solutions for B and A. If B is 3, A is 6. 2 times 6 times 3 gives us 36. B is negative 3. A has to be negative 6. All of those satisfy that. This is very CLEP type stuff right here. A simple substitution, solving using stuff we know. Okay. All right, so we now have another way to solve quadratics. Only the way we just learned, just x squareds, no x's. There are going to be some questions out there like this. 2x squared plus 3x minus 5 equals 0. Let's look at this one. Does it have just x squareds? Nope, it's got x squareds and x's. So, our first attempt would be to do what? factor, right? Because we can't try to isolate x if I have x squareds and x's. So first attempt would be to find two numbers that multiply to get negative 10 and add to get 3. Do you have two numbers that do that? Sure. So that means we could factor this. Okay, so I get 2x squared plus 5x minus 2x minus 5. This can be factored. And I get 2x plus 5 times x minus 1. And I get x equals, this would be negative 5 halves and 1. Great. X squared plus 2x minus 3. Is it just x squared? No. Could we factor this? So there are two values that multiply to get negative 3 and add to get 2. Yeah, so I would factor that. X plus 3, x minus 1, I get negative 3 and 1. Easy. Let's keep going. Next page. Skip this one, go to this one. X squared plus x plus 1. Seems simple. This has got an a of 9, so it's like whatever, skip that. Go to this one. X squared plus x plus 1. Okay, I'm thinking about factoring this. Are there two numbers that multiply to get 1 and add to get 1? Go ahead and think about it. One and 1, does that work? No, because 1 plus 1 is 2, so that should be x squared plus 2x plus 1. 1 and negative 1, does that work? Well, no, because 1 times negative 1 is negative 1, and 1 plus negative 1 is 0. So, looks like I'm stuck. And let's say, though I can factor this, I didn't know how to factor this. Okay? Well, we could have a situation where our graph doesn't cross the x-axis, and sometimes that happens. Or we could have a situation where our graph does cross the x-axis. However, we're going to be at like decimals. And when we factor, sometimes the decimals don't kind of appear to ourselves. So, my friends, don't worry. Do not stress. There is something called the quadratic formula. Okay? Did anybody learn the quadratic formula song when they were in Algebra 1? Yes? 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 X equals negative b plus or minus the square root b squared minus 4ac all over 2a. I forced my Algebra 1 students to sing that with me. It does not. So funny. No, it's a great one. Yeah, that's not going to work. But you can try. If anybody can come up with a different song, post it on YouTube. Extra points. I'll give you a lot of extra points, okay? Now, this is like some convoluted formula, right? That's like comes out of nowhere. It seems crazy. Now, I'll show you that this does not come out of nowhere. There's a proof that shows you that you can use this to solve any quadratic, okay? They took this ax squared plus bx plus c. They decided to multiply everything by 4a. They subtracted this 4ac. They then added b squared to both sides, which enabled them to factor this, which enabled them to take the square root of both sides, which enabled them to subtract the b and then divide by 2a, and boom, there's where that formula comes from. Yes, a mathematician back in the day said, like, if I can't factor a quadratic, but I know that it's going to cross the x-axis multiple times, what do I do? And they're like, boom, I found a formula. There's some smart people. There are smart people out there who just figured it out. That's how everything's created. People just figure it out. Yeah, somebody came up with it. Somebody figured it out. They didn't come out with it. They figured it out. They got there. There's other proofs out there, and people are like, oh. They were just thinking, like, how can I solve this for x? Okay, they wanted to solve for x, and they're like, the only way I could solve this for x is if I end up with something that I could square root, and I factor, and then square root, and then solve for x, and that's what they did, okay? Some people are smart, and they know what to do. So, you know, I've been playing a lot of chess, and there's some people that I play against. No. There are some people out there that already know like 8 moves in advance. And no matter what I do against them, they're going to beat me, okay? And people were thinking ahead. They're like, okay, what can I do to create this? Well, they just like to think about math problems, okay? Now, watch this. A, B, and C. These are the coefficients from ax squared plus bx plus c equals 0. Okay? So A, right there. B, right there. C, right there. Now, the previous problems we just did, we already found the solution for. But let me show you how you could use this formula to get the same solutions. Knowing that A is 2, B is 3, and C is -5. I could say, hey, I didn't know how to factor this. Let me try to use this magical formula. X equals the opposite of B. I don't like to say negative B, because if B was negative, you need to make it a positive. So the opposite of B. The opposite of B plus or minus the square root of B squared minus 4 times A times C. All over 2A. Which is 4. Okay, let's keep going. X equals -3 plus or minus. In our calculator, please type in 9 minus 4 times 2 times -5.
No.
We will need calculators for these.
All right, calculators, yeah. 4.
Type in 4 times 2 times -5, subtract it from 9. Mr. Pottorff, I'm going to be asking you exactly what this number is that goes under the square root. Oh, yeah, you need a calculator?
What order do we do it in?
It's a great question. What order do we do it in? Okay. Let's think about PEMDAS. Parentheses first, exponents next, multiplication, division. Well, you could think of the stuff in here as being a big set of parentheses that is being square rooted. I would first take the 9, subtract 4 times 2 times -5. Please do that. What do you get? Somebody have faith. 49, great. So you got -3 plus or minus root 49 over 4. This is the order we're doing it in. What is the square root of 49? 7. And it's only 7. The plus or minus is taken care of here. -3 plus or minus 7 over 4. Now let's do the plus and let's do the minus. If I did the plus, it's -3 plus 7. That's 4. 4 over 4. That's 1. Boom, 1. I already got 1. This is confirming it. Let's do the minus. -3 minus 7 is -10. -10 over 4. -5/2. Boom! -5/2. Did I have to use this magical formula to solve this equation? No, I factored it. Okay? But this is available to us. Why don't we plug in A, B, and C for this equation and confirm our solutions are -3 and 1 by using the quadratic formula? X equals -b plus or minus the square root b squared minus 4ac all over 2a. No, it gets itchy. Really? No. I've tried before. It just doesn't work for me. Like 4 days, after 4 days, it just gets it gets too itchy. Yeah. I get bumps and stuff. Why are we doing this?
Why are we doing this?
I said, why aren't we? Why are we doing this? That's another question. Why are we doing this?
Did you say that?
No, because I'm trying to teach you how to solve quadratic equations. And we already know how to factor, but now this is an alternate approach. 4 minus 4 times 1 times -3. So that's 4 minus -12, that's 16. This is -2 plus or minus 4 over 2. I got the plus, I got the minus. -2 plus 4, -2, positive 2, divided by 2, 1. -2 minus 4 is -6. -6 divided by 2, -3. Look at that. 1 and -3. 1 and -3. All right. I didn't factor this. I forgot how to factor, but I still want to know the solutions. Why don't we find the solutions to 9x squared minus 6x plus 1 equals 0 using the quadratic formula? We are now on the next page, doing the one on the top, finding the solutions. Now, this is important. A is 9, B is -6, C is 1. X equals -B does not mean you use -6. It is the opposite of B. So if B is negative, we should be using a positive 6. Plus or minus, square root. B squared, -6 squared is positive 36. Minus 4 times 9 times 1. All over 18. 4 times 9 times 1 is 36. 36 minus 36 is 0. I got 6 plus or minus 0 over 18. If I add 0 to 6, I still get 6. Divide by 18, I get 1/3. If I subtract, I still get 6. Divide by 18, I get 1/3. Turns out this only has one solution. If I factored this, we'd get 3x minus 1 times 3x minus 1. Another way to confirm my answer is just 1/3. However, let's look at the next one. The next one, I couldn't factor. It's impossible. But let's see if there are solutions. Maybe it's a situation where we do cross just at crazy decimals, and sometimes that happens. So A is 1, B is 1, C is 1. I get x equals negative b, opposite of b, plus or minus, square root, b squared, which is just 1, minus 4 times 1 times 1, all over 2 times a, which is just 2. Everybody with me so far? Mr. Potov, what is underneath the square root? Give me the numerical number that is under the square root. Don't just repeat what is on the board. Negative 3. Type into your calculator the square root of negative 3. What do you get? Whoa. What do you get? You get an error, right? Can you take the square root of negative 3? No, it's an imaginary number. We'll talk about those later in this class. So, since I end up with this, turns out there are no solutions. So this graph of x squared plus x plus 1, if you looked at it, it's actually above the x-axis. It does not touch or cross the x-axis. Now, what's great about the quadratic formula is the information that ends up underneath the square root will be able to tell us whether we have 2, 1, or no solutions really quickly. When I had the square root of 49, that's 7. I had to add and subtract 7, giving me 2 answers. I had the square root of 16, that's 4. I had to add and subtract 4, giving me 2 answers. When I had the square root of 0, I added and subtracted 0. Well, it didn't change anything. It just gave me 1 answer. When I had a negative under my square root, that's telling me I can't do it. There's no solutions. This is called the discriminant. The discriminant is just the stuff under square root in the quadratic formula. Namely, it's b squared minus 4 times a times c. If the stuff under the square root ended up being positive greater than 0, we had 2 solutions. If the stuff under the square root was 0, we end up having 1 solution. If the stuff under the square root was negative, there's no solutions. So without having to factor, without having to use the entire quadratic formula, you can quickly and easily tell me if these 3 equations will have 2 zeros, 1 0, or 0 zeros. We're trying to find the zeros.
Why do you flip the b and from like a
The opposite of b. It's negative b. If b is negative, that becomes positive. Opposite of b. Got that? So in the previous one, yes, B was -6, but it's the opposite of B, +6. Well, the other ones you don't have to flip. It's like B squared minus 4 times A times C, 2A. There's no negatives besides the minus sign. Okay? B squared minus 4, sorry, B squared is just 4. -2 squared is 4. Please do not make a mistake in your calculator and write -2 squared in your calculator and it tells you it's -4. Use parentheses. You should just do these squares in your head. -2 squared is 4. 4 times A times C. I can tell right now this is a negative. What is it? -28? What is that telling me in terms of the amount of zeros that the equation has? There are no zeros. There are no solutions. Follow with me, gentlemen. Figure out, for these two, how many solutions are there? I don't care what the solutions are. I just want you to tell me how many there are. What was it, 65? I don't care. It's greater than 0. Okay, now for the previous problems, I could have tried to factor, and whether or not I factored or not doesn't necessarily, tell me that I'm going to get the same answer. What you guys need to know that moving forward, you have this in your arsenal. You do not have to use a certain method if you do not want to, unless you're asked to. If you're asked to find the zeros of this equation, you could factor. It is very easy to factor this and find the solutions. My recommendation for you guys is to always attempt to factor first. If for some reason you can't figure out the numbers, you can't factor, use the quadratic formula. -b plus or minus the square root b squared minus 4 times a times c all over 2a. This is -48. 1 minus -48 is positive 49. -1 plus or minus the square root of 49 over 2. Square root of 49 is 7. We have the positive. We'll have the negative. -1 plus 7 is 6 over 2. 3. -1 minus 7 is -8 over 2. -4. You get the same solutions no matter which technique you use. Moving forward, it is up to you to use the correct technique. Okay? These two, I'd recommend you just factor. This is the same one that we just did. But for these ones, factoring may not be an option. Let's look. 4 times 1, 4. 4. Can I factor this? Two numbers that multiply to get 4 and add to get 4? Yeah, I can factor it. So maybe you factor this one. Let's see this one. 2 times negative 9, negative 18. 3. Two numbers that multiply to get negative 18, add to get 3. Yeah, I could do that. I want to get one where there is no. Whatever. Pretend you forgot how to factor. Find the solutions using the quadratic formula, just as practice. Pretend you forgot how to factor. All right, I'm going to change my mind. The one on the right, change this to minus 10. So the one on the left quickly, and then the one on the right is going to be the one where it's like we have to use the quadratic formula. I did not set up these notes very well so that we had ones that we had to use quadratic formula. Two x squared plus 3x minus 10. I can't factor this. There are not two numbers that multiply to get negative 20 and add to get positive 3. They don't exist. Factoring isn't going to help us. But the quadratic formula will. Everybody do the one on the right. You are not going to get nice answers.
How do you not get a solution if you try to factor it?
I could check using the discriminant. B squared, 9, minus 4 times 2 times negative 10. 9 minus 8 times negative 10 is negative 80. So it's 9 plus 80. That's 9. It's 89. That's a positive number. So I'm going to be able to take the square root of it. There will be a solution. C is negative 10. Come on, come on, come on, keep going. I want you to use your calculator and actually find these values. Now, b squared minus 4ac ends up being 89. 89. Change that to a negative 10. That changed the problem. Let's look at our calculator. Come on, what are you doing? What is going on? I'm literally clicking it. Oh my goodness, why are you doing this? All right, here we go. Root 89 is not a nice number. Right. When I get a non-nice number like that, I don't want to use a decimal, because if I start approximating, all of a sudden I'm going to get some wrong answers. Now I could use this exact number and take negative 3 and add it to it, divide by 4. And if I write down all of the decimal places, I'm close to being correct. Can I make it a fraction? Let's see. Doubt it. Nope. Nope. That square root of 89 is not going to work well with me. If I take that negative 3 and subtract this decimal and then divide by 4, I get negative 3.108495283. Nope. Nope. These are the answers. I'm just telling you right now, those are the answers. However, I don't want to write decimals out like that. So what I'm going to do is actually just write it out as negative 3 plus root 89 over 4 and negative 3 minus root 89 over 4. Those, my friends, are the solutions. I guarantee you, I'll show you. Let's graph. 2x squared plus 3x minus 10. And you're not allowed to do this because you're not allowed to use these graphing calculators. Zoom standard. Okay. We're looking for these zeros, right? I'm hoping this is negative 3.1. This is like 1.6. I could calculate a 0 as long as I go to the left of it and to the right of it. My calculator will find negative 3.108495. That's what I have right there. Let's find the other one. Calculate the 0. To the left of it. To the right of it. 1.608495.3. Okay? The quadratic formula helps us find solutions that are not found through factoring. Okay? Why don't we do another one like that? And I want you to leave your answers in simplified radical form like this. Let's change this from x squared minus 16 to x squared plus x minus 16. Find the zeros or the solutions using the quadratic formula. The graph crosses through the x-axis twice. I know this is true because b squared minus 4 times a times c is positive. Negative 16 times 4 subtracted from 1 is a positive value. So that means I do have two solutions. Let's find those two solutions using the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a.
For BC or for AC?
For AC. X equals negative b plus minus square root b squared minus 4ac. Write down your answers. Write down your two answers. $64, so that's 65. Those would be my two answers. So last one. Go ahead and try factor the last one. Let's see. X minus 4, x minus 1. Does that work? Nope. Negative 4 times negative 1 is positive 4. I need negative 4. That doesn't work. X minus 5x plus 1. Nope. That won't work. This can't be factored. You have to use the quadratic formula. Use the quadratic formula. Now, negative b. b is negative 5. What would be negative b? 5 plus or minus square root b squared 4ac all over 2a. 25 plus 16 is 41. I get two solutions.